Hello and welcome. Today we are tracking a ghost in the machine of our solar system, a visitor that has traveled light years to reach us, only to begin behaving in ways that defy our standard models of cometary physics. We are talking, of course, about the interstellar object designated 3I Atlas, also known as C2025N1. As of today, December 8, 2025, astronomers from Washington to Moscow are scrambling to interpret a stream of baffling data. The headline is simple, but the implications are profound. Our guest is fading, just as it should be waking up, roaring into life under the heat of our sun. 3I Atlas is going quiet. Before we dive into the orbital mechanics and the thermal physics that make this event so unprecedented, if you want to stay ahead of these breaking deep space discoveries, make sure you are subscribed to the channel. We track these objects in real time, and you won't want to miss what happens as we approach the critical window later this month. Now, let's set the scene. Imagine a traveler walking towards a bonfire. As they get closer, you expect them to get warmer, to shed their heavy coat, to become more visible against the dark background. That is the fundamental rule of comets. As they approach perihelion, their closest point to the sun, the solar radiation heats their icy nuclei. This heat causes sublimation, turning frozen gases directly into vapor, creating the glowing coma and the spectacular tale that we associate with these celestial wanderers. But 3I Atlas is doing the exact opposite. It is walking towards the fire, and it is dimming. Let's look closer at the data coming in from the global network of observatories. As of the last 48 hours, specifically December 7th and 8th, the brightness of the comet is decreasing. This isn't a trick of the light or an atmospheric disturbance on Earth. It is a physical change in the object itself. The coma, that gas-dust envelope that surrounds the solid core, is contracting. It is shrinking. We are seeing a reduction in the scattering of light, which tells us that the output of gas and dust has throttled down significantly. This is happening while the object is still visible through telescopes, currently sitting at a magnitude of about 10.9. To the naked eye, it is invisible, lost in the blackness, but to the lenses of our planetary defense network, it is a distinct, albeit fading, smudge of light. The object is currently moving through the constellation Virgo, slowly drifting toward Leo. It is a silent passage, but the silence itself is the mystery. Why is this significant? Because we are days away from its closest approach to Earth. On December 19th, 3I Atlas will be at a distance of about 270 million kilometers from our planet. In astronomical terms, that is a safe distance. There is absolutely no threat of collision, and we need to be very clear about that. This is not a Hollywood disaster movie scenario. However, it is close enough that we should be seeing a crescendo of activity. We should be seeing the fireworks of interstellar chemistry on full display. Instead, we are watching a candle flicker in the wind. The scientific community, including teams from NASA and the European Space Agency, ESA, are currently in a state of high alert, not out of fear, but out of intense curiosity. They are monitoring this object around the clock because understanding how such guests from other star systems interact with our sun is the holy grail of modern planetary science. We have only had a handful of confirmed interstellar visitors. Oumuamua was the first, a tumbling cigar-shaped rock that puzzled us all. Then came Borisov, which looked and acted much more like a traditional comet. 3I Atlas was supposed to be the tiebreaker. It was supposed to tell us if Oumuamua was the exception or the rule. But 3I Atlas is writing its own script. The fading brightness suggests that the volatile ices on its surface, the fuel for its cometary engine, might be exhausted, or perhaps a crust of insulating dust is forming, sealing the vents and choking off the sublimation process. Or, and this is the theory that keeps astronomers awake at night, the nucleus itself might be disintegrating, but in a way we haven't seen before. Usually, when a comet breaks up, we see a flare in brightness as fresh ice is exposed to sunlight. A sudden dimming is counterintuitive. It forces us to ask, what is this object made of? If it's not behaving like a snowball from our own Oort cloud, does it have a composition that is fundamentally alien to our solar system? Is it a shard of a nitrogen ice planet, a porous aggregate of organic compounds that darken when heated? The contracting coma implies that the pressure pushing the gas out is dropping. The atmosphere of the comet is collapsing back onto the surface or dissipating into the vacuum faster than it can be replenished. We are looking at a velocity of roughly 60 kilometers per second. That is a staggering speed. At that velocity, it is piercing the solar wind, interacting with the magnetic fields, and the stream of charged particles flowing from the sun. Yet, it seems impervious to the solar wake-up call. The amateur astronomy community has been instrumental here. While the big space telescopes like Hubble have strict schedules, amateur astronomers with sophisticated gear, like the Seestar S50 telescope, are watching the sky every single night. Their data from December 7th confirms the professional assessment, a compact coma, diameter of only 2 to 3 arcminutes. That is tiny. It's a pinprick. And crucially, they report no fragmentation of the nucleus. The heart of the comet is still intact, at least optically. It hasn't shattered into a cloud of debris, which would explain a disappearance. It is simply turning off. This brings us to a fascinating juxtaposition. While the comet is fading, it is physically passing through a very busy part of our sky. It recently passed near Jupiter, creating a stunning visual tableau next to the waning moon. For photographers, it was a moment of beauty, a fading interstellar ghost, the giant king of planets, and our own moon, all in one frame. But for scientists, that proximity to Jupiter serves as a reminder of the gravitational gauntlets these objects run. While Jupiter isn't close enough to capture 3I Atlas, the sheer scale of the solar system makes this visitor's journey even more precarious. We must consider the possibility that 3I Atlas is a dark comet in the making. We have seen objects that lose their volatiles and become asteroid-like, dark, inert rocks tumbling through the void. Is that what we are witnessing? The death of a comet in real time? Or is this a pause, a temporary lull before a sudden outburst? The history of cometary observation is littered with surprises. Comets are notoriously unpredictable. As the famous comet hunter David Levy once said, "Comets are like cats. They have tails, and they do precisely what they want." 3I Atlas is proving to be a very stubborn cat. But there is more to this story than just a dimming light curve. To understand why this is happening, we have to go down to the molecular level. We have to understand the engine that drives a comet. We have to talk about sublimation, about the fire hose effect, and about the specific chemical signature that 3I Atlas is, or was, broadcasting to the universe. Because hidden in that fading light is a chemical code, a fingerprint of the star system where this object was born billions of years ago. And despite the dimming, we have managed to read some of that code. What we found is puzzling. It suggests a mechanism of release that was violent and copious, only to shut down abruptly. It suggests a structure that is perhaps less like a solid rock and more like a fragile lattice of ice and dust, barely held together by its own weak gravity. As we move deeper into this investigation, we need to strip away the assumptions we make based on our local comets. We need to look at the physics of sublimation in a vacuum under the specific radiation pressure of our Sun, applied to materials that may have formed in a nebula with a completely different chemical balance than our own. The fading of 3I Atlas is not the end of the story. It is the plot twist. It is the moment where the detective realizes the clues don't fit the crime. If the comet is intact, and the Sun is hot, and the ice is there, where is the gas? Where is the tail? To answer that, we have to look at the fire hose data. We have to look at the water and the CO2. And we have to ask ourselves, did 3I Atlas run out of fuel? Or did something else turn off the tap? As we established in the previous chapter, the interstellar comet 3I Atlas is fading at a time when it should be brightening. To understand why this is such a baffling anomaly, we need to get our hands dirty with the physics of the situation. We need to look under the hood of the celestial engine. The process driving any comet is sublimation. This is a phase transition where a substance changes from a solid to a gas without ever passing through a liquid phase. Think of dry ice, frozen carbon dioxide, smoking on a table. That is sublimation. Now imagine that happening in the vacuum of space, bombarded by the intense radiation of the Sun. For a typical comet, the nucleus is a dirty snowball, a mix of water ice, frozen gases like carbon dioxide and carbon monoxide, and dust. As it falls towards the Sun, the heat penetrates the surface. The ices turn to gas, expanding violently. This gas rushes out into the vacuum, dragging dust particles with it. This outflow is what creates the coma, the atmosphere, and the tail. It is a simple thermal equation. More heat equals more gas, which equals a brighter comet. But 3I Atlas is breaking this equation. Recent data confirms that 3I Atlas has been releasing water in a manner that scientists have compared to a fire hose. This isn't a gentle seep, it is, or was, a high-pressure jet. The term fire hose implies a directional, forceful ejection. It suggests that the water wasn't just sublimating from the entire surface evenly, but perhaps blasting out from specific vents or fissures in the crust. This kind of activity usually indicates a rich reservoir of volatiles near the surface. It tells us that the comet is active, dynamic, and reacting strongly to the solar environment. However, the latest observations from December 7th and 8th show that this activity is decreasing. The fire hose is being turned down to a trickle. This contradicts what we previously thought about the internal structure of this object. If the comet were a simple chunk of ice, the increasing solar heat as it approaches Earth should be ramping up the pressure, not lowering it. The fact that the activity is dropping while the heat is rising suggests that the fuel tank might be empty. Or at least the accessible fuel is gone. This phenomenon is known as outgassing exhaustion. It is possible that 3I Atlas had a thin layer of surface ice that has now boiled away, leaving behind a dead, rocky core. This would make it a Manx comet, a rocky body with a very short-lived tail. But the fire hose intensity seen earlier argues against a thin layer. It suggested depth. Another possibility is crustal formation. As the volatiles boil off, the dust and heavier rocks are left behind. They can fall back onto the surface, forming a lag deposit, a thick, insulating blanket of dust. This blanket acts like a thermos, shielding the ice underneath from the sun's heat. If this crust forms quickly enough, it can choke off the jets, sealing the comet up like a pressure cooker. This would explain the contracting coma. The gas supply has been cut, and the existing cloud is dissipating. But here is the crucial detail that makes this specific to 3I Atlas, the speed of the shutdown. A gradual decline is one thing. A rapid drop-off in brightness over 48 hours is another. It implies a catastrophic change in the surface topology or the sublimation mechanism. We also have to consider the chemical composition. We mentioned water and CO2, carbon dioxide sublimates at much lower temperatures than water. Often, comets have a turn-on point far out in the solar system driven by CO2, and a second boost when they get closer and water ice starts to sublimate. 3I Atlas is currently in the zone where water sublimation should be dominant. If it is shutting down now, it might mean it is water poor. It might have been a CO2-rich object that has simply run out of its primary volatile. This leads us to a fascinating question about its origin. If 3I Atlas lacks water ice compared to our local comets, what does that tell us about the star system it came from? Was it formed inside the snow line of its parent star, where it was too hot for water to freeze, only to be ejected later? Or is it a fragment of a larger body that was stripped of its water eons ago? The speed of the object, 60 km redress, reminds us of the immense kinetic energy involved. While this speed doesn't directly affect sublimation, the vacuum is the vacuum regardless of speed. It determines how quickly the comet moves through different thermal zones. 3I Atlas is plunging through the inner solar system relatively quickly. It doesn't have years to bake. It has weeks. This rapid transit creates a thermal shock. The surface heats up fast while the core remains at near absolute zero. This thermal gradient can cause fracturing. We mentioned earlier that there is no sign of fragmentation yet, but the stress is there. The fire hose might have been the result of a thermal fracture opening up, spewing gas, and then perhaps collapsing or being blocked by debris. The internal plumbing of a comet is complex. It's not just a ball of ice, it's a porous, cavernous structure. Vents can open and close. Chimneys can collapse. So, what does this actually mean for the observer? It means we are watching a dynamic geological process on a world that is 270 million kilometers away. We are watching a celestial object try to survive the heat of our star. And right now, it looks like it is losing the battle. The coma is shrinking because the gas isn't being replenished fast enough to counter the solar wind blowing it away. This brings us to a point of speculation that we need to address carefully. Some might ask, could this behavior be artificial? Could the fire hose be something else? We will get to the artificial debate in a later chapter, But purely from a physics standpoint, everything we are seeing, the acceleration, the coma, the dimming, can be explained by natural, albeit complex, thermodynamic processes. The mystery isn't, is it aliens? The mystery is, what specific combination of ice and dust creates this unique curve of death? We are currently in a waiting game. Will the heat eventually penetrate the insulating crust and cause a second outburst? Will the comet break apart under the thermal stress, revealing fresh ice and brightening suddenly? Or will it fade into a dark, invisible rock, a silent ghost passing in the night? I want to hear your take on this. Do you think 3I Atlas is just a dud comet running out of gas? Or do you think we are seeing a complex crust formation that might lead to a massive outburst later? Leave a comment below with your theory. I read through them to see what the community is thinking. Building on this understanding of the invisible mechanics, we need to look at what is actually visible. Because despite the dimming, 3I Atlas is putting on a show for those who know where to look. The data from the Seestar S50 telescope gives us a very specific picture of what is happening right now in the constellation Virgo. It's time to shift our gaze from the physics equations to the eyepiece. Building on this understanding of the invisible mechanics, we turn our attention to the visible reality. While the scientists crunch the numbers on sublimation rates, the amateur astronomy community is doing what it does best, keeping eyes on the sky. And the data coming from their backyards is proving to be just as critical as the feeds from billion-dollar observatories. Fresh observations from December 7th, obtained by amateur astronomers from Hawaii using the Seestar S50 telescope, have given us the most up-to-date snapshot of 3I Atlas. The Seestar S50 is a smart telescope, a piece of consumer tech that automates the tracking and stacking of images, allowing enthusiasts to capture deep sky objects that would have been impossible to see from a driveway just a decade ago. What these images show is a compact coma with a diameter of 2 to 3 arcminutes. To put that in perspective, the full moon is about 30 arcminutes across. So, the coma of 3I Atlas appears roughly 1/10 the width of the moon in our sky. It is small, it is condensed, and, most importantly, the images show no fragmentation of the nucleus. The core is a singular point of light. This is vital because it tells us the dimming isn't due to the comet scattering its mass into a diffuse cloud. It is still a coherent body. The comet is currently located in the constellation Virgo, a vast field of galaxies and stars. It is slowly moving toward Leo, the lion. This trajectory places it in the morning sky for most observers in the northern hemisphere. If you are in a region like Rostov, or anywhere with a clear view of the southeastern horizon, the pre-dawn hours are your window. However, visible is a relative term. With a magnitude of about 10.9, 3I Atlas is far below the threshold of the naked eye, which is around magnitude 6. You cannot just walk out and look up. You need binoculars, good ones, or a small telescope to spot it. It will appear as a fuzzy, faint star, a smudge of gray against the black. But the fact that it is visible at all is a testament to its size and activity, even as it fades. Here is the crucial detail that made the last few nights so special: the cosmic backdrop. While 3I Atlas was performing its disappearing act, it passed near Jupiter. This conjunction created a spectacular view next to the waning moon. Imagine the scene: the brilliant, steady glow of Jupiter, the sharp crescent of the moon, and nearby, this faint, mysterious visitor from another star system. It was an ideal moment for astrophotographers. The contrast was poetic, the ancient stable giants of our solar system witnessing the fleeting passage of an interstellar traveler. These images are more than just pretty pictures. They provide astrometric data. By measuring the comet's position relative to the background stars in these photos, astronomers can refine its orbit. We know it is moving at about 60 kilometers, but precise tracking helps us determine if any non-gravitational forces are acting on it. Remember the fire hose effect? If gas is shooting out, it acts like a thruster, pushing the comet slightly off its purely gravitational path. Tracking these minute deviations helps us estimate the mass and the rate of mass loss. Russian sources have noted that the comet is one of the key astronomical events of December, ranking alongside the Geminid meteor shower and the supermoon on December 4th. It is part of a busy month for the night sky. But unlike the Geminids, which are clockwork and predictable, 3i Atlas is a wild card. Astronomers in these regions are noting the loss of brightness with keen interest, suggesting it may indicate changes in the nucleus composition. The visual data also reveals the color, or rather, the lack of it. To the eye, comets often look gray or white, but in long exposure photography, they can reveal green from diatomic carbon or blue from ionized carbon monoxide. The current reports describe a fairly neutral color, which aligns with the shrinking coma. If the gas production is dropping, the glowing halo that gives a comet its color is fading, leaving us with just the sunlight reflecting off the dust. This visual contraction is what makes the compact coma description so important. A large, diffuse coma means lots of gas. A compact, sharp coma means less gas, or a younger, less developed atmosphere. For an object this close to the Sun, compact is code for underactive. The community on social media, particularly on X, formerly Twitter, is buzzing with these images. You can see the progression day by day. A week ago, the comet looked fluffier, brighter. Now it is tightening up. It's like watching a flower close its petals. But as with any mysterious object in the sky, the visual data is only half the conversation. The other half is interpretation. And where there is a gap in our understanding, speculation rushes in to fill it. The Internet is currently awash with theories about what 3i Atlas actually is. Some are pointing to morphological features in the images, shapes that don't look quite right. Others are talking about an anti-tail. This connects to a broader phenomenon in modern science communication, the speed at which data becomes conspiracy. The Seestar images are raw data. The interpretation of that data, however, has taken a life of its own. From biblical prophecies to alien propulsion systems, the dimming of 3i Atlas has triggered a wave of debate that goes far beyond astronomy. So, what does this actually mean? Is there anything anomalous in the shape of the comet? What is an anti-tail, and why are people claiming it proves artificial origin? To separate the signal from the noise, we need to look at the specific claims being made and hold them up against the light of physics. Given what we now understand about the visual data, it was inevitable that the Internet would find patterns in the noise. The human brain is a pattern recognition machine. We see faces in clouds and canals on Mars. With 3i Atlas, the mystery of its dimming has created a vacuum, and that vacuum is being filled with some truly wild theories. On social media platforms, including X, a parallel narrative is unfolding. While scientists talk about sublimation and dust crusts, a significant portion of the online community is discussing morphological features that they claim resemble artificial objects. The most prominent of these discussions centers on the anti-tail. In some images, observers have noted a spike of light pointing towards the sun rather than away from it. To the uninitiated, this looks like a thruster. It looks like an engine firing to slow the object down or change its course. This has inspired ideas about new cosmic propulsion systems, fueling speculation that 3I Atlas is not a comet at all, but a probe. So, what does this actually mean? Is the anti-tail a sign of alien technology? The answer is almost certainly no. An anti-tail is a well-understood optical illusion. It happens when the Earth crosses the plane of the comet's orbit. We are looking through the sheet of dust that the comet has left behind. From our perspective, this dust sheet appears to project forward, creating a spike that points toward the sun. It is a geometric alignment, a trick of perspective, not a propulsion signature. We have seen it with Comet Rowland, Comet Pan-STARRS, and many others. It is rare, it is beautiful, but it is natural. However, the speculation doesn't stop there. Some posts are linking the comet's trajectory and timing to biblical prophecies, viewing the dimming star as a harbinger. Others are analyzing the light curve and claiming that the color change, or lack thereof, indicates a metallic surface rather than ice. This is where we need to bring in the voice of reason. Scientists, including Brett Tingley from Space.com, have been active in refuting these rumors. They emphasize a simple truth. It's a comet with gas jets. The anomalies are only anomalous if you don't understand the complexity of cometary physics. Tingley and others point out that the color change is a misunderstanding of how filters work in astrophotography. A comet might look green in one filter and white in another. The loss of brightness is not a cloak being engaged. It is the exhaustion of volatiles we discussed in Chapter 2. The morphological features, the lumps and bumps seen in low-resolution images, are often artifacts of the image processing itself, or simply the irregular shape of the nucleus being illuminated from different angles. But why does this artificial origin theory persist? It goes back to Oumuamua. That object was so weird, so thin, so accelerated, that serious scientists, including Avi Loeb from Harvard, suggested it might be artificial. That opened a door in the public imagination. Now, every interstellar object is scrutinized through that lens. 3I Atlas is the second act in a drama that Oumuamua started. The difference is that Oumuamua didn't have a coma. 3I Atlas does. It has a tail. It releases water. It behaves chemically like a comet. The artificial argument for 3I Atlas is much weaker because we see the gas. We see the mechanism. If it were a spaceship, it's doing a very good impression of a dying snowball. Yet the intrigue is building for a valid scientific reason. Even if it's not a spaceship, the morphological features might indicate that 3I Atlas is not a single solid rock. It could be a rubble pile, a collection of rocks held together by gravity. Or it could be a contact binary, two objects stuck together like a snowman. If the neck connecting them breaks, we could see the fragmentation that everyone is watching for. The anti-tail debate while scientifically explainable, highlights how closely people are watching. It shows a public hunger for discovery. People want it to be something special, and in a way it is. It is a sample of material from another star system. It contains isotopes and molecules that were forged in a nebula far from our own. That is miraculous enough without needing it to be a spaceship. The skepticism is healthy, but the data must rule. And the data says, natural object, unusual behavior. The fire hose was real, but it was a geological event, not a mechanical one. The dimming is real, but it's a thermal event, not a stealth mode. As we move toward the date of closest approach, the window for wild theories is closing. The data is getting better. The images are getting sharper. Soon, we won't have to guess. This connects to the final phase of our coverage. We have looked at the physics, the observations, and the rumors. Now we need to look at the calendar. December 19th is the date everyone is circling. It is the moment of truth. What happens when this fading ghost gets as close as it's going to get? Will it break? Will it wake up? Or will it simply vanish? The scientists at NASA and ESA aren't just debunking rumors. They are preparing for a potential gold mine of data. If the comet fragments, it opens its interior to our telescopes. It spills its secrets, and that is what we are waiting for. As we established, the speculation surrounding 3I Atlas is intense, but the timeline of reality is ticking forward. All eyes are now fixed on December 19th. This is the date of closest approach to Earth. The comet will pass at a distance of about 270 million kilometers. To be clear, in the vastness of space, this is a comfortable margin. It poses no threat to our planet. But scientifically, it is a close encounter of the most valuable kind. This date represents a critical threshold. It is the moment when the geometry of observation is optimal, even if the comet itself is fading. Scientists from NASA and ESA continue monitoring to understand how such guests from other star systems interact with the Sun, and this specific window is their best chance to gather data on the nucleus itself. If the coma continues to contract, the fog around the comet clears. Paradoxically, a dying comet can be easier to study than an active one. Without the blinding glare of a massive coma, powerful telescopes like Hubble and the James Webb Space Telescope, if targeted, can peer directly at the solid core. They can measure its size, its rotation rate, and its surface reflectivity, albedo, with much greater precision. The intrigue is building. If the comet contains rare molecules or shows unexpected fragmentation by December 19th, it could reveal secrets of interstellar chemistry. We are looking for prebiotic molecules, the building blocks of life. Did comets like this one deliver the ingredients for life to the early Earth? If we find complex organics on a visitor from another star, it suggests that the recipe for life is universal, not unique to our solar system. Astronomers await updates from Hubble and ground-based observatories with bated breath. Perhaps new images will confirm or refute the anomalies we discussed. Perhaps they will show a hairline fracture in the nucleus, a precursor to a breakup. If 3I Atlas does fragment, it would be a scientific jackpot. It would expose the fresh, unaltered interior of the comet, material that hasn't seen the light of a star for billions of years. We are also watching this object as part of NASA's planetary defense programs, not because 3i Atlas is a danger, but because it is a test case. It tests our ability to detect, track, and characterize an interstellar object on short notice. It tests our models of non-gravitational acceleration. Every data point we gather improves our ability to predict the path of the next visitor, one that might not be so distant. The fire hose behavior we saw earlier, even though it has stopped, is a key piece of this puzzle. It tells us that these objects are volatile. They are not just rocks. They are active participants in their environment. Understanding how they turn on and turn off is crucial for predicting their orbits. So, what is the final verdict on 3i Atlas? It is a mystery in motion. It arrived with a promise of fireworks and is leaving with a whisper. But that whisper is full of information. It tells us about the diversity of the galaxy. It tells us that not all comets are created equal. And it reminds us that the universe is still capable of surprising us. Keep an eye on the sky. December promises more discoveries. The story of 3i Atlas isn't over until it fades completely into the dark. Whether it breaks apart or simply drifts away, it has already changed our understanding of what an interstellar comet can look like. If you enjoyed this deep dive into the science of the unknown, please hit the like button. It helps us bring more of these investigations to you. And keep looking up. You never know what might be passing through.